Hello.
Good morning.
All right, we're gonna wait another 2 minutes for people to join. I know I saw someone else in the waiting room, so they're joining right now. Okay, hi Bill, hi Hugo. I think we're gonna start now. And since there's only 2 of you, I first wanted to kind of ask how far along you guys have been with the training process. If you've been evaluated yet, or what kind of materials you've looked at so far. If you want me to go through everything from step 1, that's fine too.
I look at some Scratch+AI, but I didn't really go deep into it. Yeah, but I know Java and Python well.
Okay, cool. And about Adele, what do you think? You can put it in the chat too if you're like somewhere you can't talk.
Hello,
Yes, I can hear you.
I have experience with Visual Basic, C#, and some experience with Python.
I see. Okay. I'll go through the curriculum then with Scratch. I probably won't get through every single lesson, but we'll kind of go through the resources that are available to you guys. We'll go through, kind of basic teaching tips as well, and what you can do when problems arise. So hopefully, if you guys all know how to log into school.thinkland, you should go to the Start Here dashboard. In the Start Here, you'll be able to find training for all the courses. And so you'll also find the Scratch and AI course And you should definitely like 100% go and join the Scratch and AI classroom. And this will help you, this will give you access to all these resources that I'm going to talk about. So just let me know in the chat if you need help with that for a second. But if you go click on that, you'll find all of these at the beginning. And so this is a training course. These I found very useful when I was first starting to learn how to teach the course. We have these things like a teaching checklist, kind of things to go through. These are more like general tips for teaching, like you need to do attendance, arriving to class, et cetera, et cetera. This is just kind of tips with making your ML model, which I'll go through. This one, the resources for the videos, I think is really helpful because it kind of contains example lesson plans or example for the lessons. And it also walks you through the content. And I use this for reference when I'm trying to learn the material, as well as trying to learn how to present the material to the students. And so I kind of said in the page earlier that this is mainly for 9 to 12-year-olds. There are definitely cases in which you could be teaching kids that are possibly younger. For example, right now, I'm actually teaching a 6-year-old this class, which is pretty crazy. But, when things like that happen, you definitely adjust the way that you teach and the way that you present your information. Class pacing, this Google Doc or this document is also very helpful. Usually these are 16-hour sessions. And so it kind of breaks it down into, how many hours each project should take. And, even if that varies a little bit, that's also okay. So I'm just going to kind of start with the intro to machine learning, this first lesson here. There's a couple of things to look at. We have the presentation, which is usually what you'll go through with your students at the before you start your ML model. Now, these presentations can be a little bit long. So if you are teaching, that's a little younger, or, maybe your kids just don't have the attention span, it's okay to also reduce this, make this shorter. I usually like to make a copy of these presentations and edit them how I like it. And so you can choose to skip over certain slides. You can just edit some. For example, videos, a lot of kids don't like them. Even if they're short videos, it just kind of breaks their concentration. They typically like discussion a little bit better. Also, like I said, I'm teaching a 6-year-old. Sometimes, there's too much text on the screen. You can, reduce this down, make it simpler, and try to focus on sometimes different things in the content. So there's like a little Pictionary game in this first lesson, which is pretty great. Kids usually like it. So finding games like, let's see. Finding games like this, if you want to find it yourself or you know of a game, you can add it into your lesson plan. IO Learning, they pretty much give you a lot of freedom over your lessons. And so you are allowed to even make your own presentation to go through these concepts if you wish. And so they add little games like this, which is, the quick draw made by Google, where you just draw things and Google guesses it. These are things that you can implement into the plan to make it a little more engaging for your students. And so I'm not really going to go through exactly all of this. This is definitely one of the longer presentations. It goes through what is AI, has a video, strong AI, weak AI. It's very good to talk about like real life examples. Like sometimes if they like Marvel, I talk about, Tony Stark and his AI or whatever. I sometimes talk about the Transformers. Real life examples are really useful. A lot of kids have an Alexa that you can refer them to. Keep going. These are also like real life examples. Some kids really like chess. We have Jeopardy. We have Go. These are all things that are relatable to students. And then we start talking about machine learning. What is machine learning? How do we compare it to human learning? That's something that's really done at almost every step of the project, because you're going to start talking about different types of machine learning, like image recognition, natural language processing. Each time we compare it to how humans learn and then how machines go about doing that same function. Yeah, like these are sometimes, I usually like to skip like this slide. It really depends on the students and what you think will be beneficial for them. Yeah, now at the end, you're going to say, let's create our own machine learning model. It's actually going to be an apple and orange program. I don't know why in the slideshow it says apple and pear. So then to work on your machine learning model, you'll click on, it says first ML model with a little plug. Just gonna open that up. Right now, it's actually not exactly working. Actually, I could test it and see if it's working, but yeah, we have apple and pear. And then we have to give it each a certain number of images, usually 10, sometimes it's different for the different models. What's happening here, we start by setting our labels. So what are the things that we want to differentiate between? This is an apple and a pear model. So one label says apple, one label says pear. We can see it says image recognition because that's what it's going to be doing. And so we're going to be giving it images. Usually it's 10 images to each. And there's multiple different ways to upload these images. Oh, and feel free to stop me anytime if you have any questions. So here, there are multiple different ways to put in these images, and that's something you'll have to work to help your students figure out. So you see here, we have webcam, upload, www, and draw. The webcam and the draw usually aren't very relevant to what we're doing. You usually want to use upload or the www. Upload means, you got to download the image to your laptop and then upload it here. But I usually don't recommend that method because a lot of kids don't know how to upload an image from their files. They don't really know how to work the files of their laptop. So the other method I really do suggest is this www. So you go and find an Apple image. You tell them to right click, copy image address, and then you can paste that in into the www, gives you the URL. Another method, which I find is actually the easiest, is if you just drag and drop. So I'm grabbing the image and I drop it right here. That is honestly the best way that I've found to work with this. Same thing for the pair, obviously. Sometimes you'll get like little errors. It might give you like sometimes the image just won't show because it's not a compatible file type. In that case, just click on the little X right here and it'll go away. So yeah, the drag and drop method is usually the best. Second best, I'd say, is using the URL link. After, we're going to go to this number 3, and it tells you that you need to train your model. And that's going to take a few minutes, or more like just a minute or two. Yeah, so right now, the machine learning model, it's not working on ThinkLens right now because of issues on their side. It's not my laptop, but usually you'd click train the model, it'd take like a minute, and then you get like a little blue screen. And every time you come back to this page, you also want to check this number 3, make sure the model is trained, because sometimes, if you come back to it after a week, it says, the model is deleted or something. So you have to go back and retrain it. In this number 4, I'll test it with the students and also go over some concepts. So this is the same idea. It would tell you to upload an image here, and I would do it by the same methods I use for entering the training data. You got to make sure you use pictures that have not been used before, because if you use a picture that's been used in the training data, it's going to be 100% accuracy rate. Over here, it's going to show you, it would give you like the label name, the prediction. So it's like apple or pear, and it give you like a percentage for the confidence level. And so this is when I kind of talk to my students about what is confidence level, or like just making predictions together. Do you think the computer will say this is an apple or pear? And then sometimes they also test, okay, what if we put like a watermelon in here? What if we put something that's not an apple or pear? Usually they'll say like, oh, it's going to give us an error. But that's not how ML models work. It's only ever going to give us the predictions of the one of the two labels. And then it kind of talk to them a little bit more about why is it that that happens? How does machine learning model work in those ways? After that, you test it, you go to launch Scratch down here, and that's going to give you access to Scratch. For basically all of the projects you'll work on, they'll give you, IO Learning gives you a template to work off of. So you go up here into project templates and you get this apple or orange template. And then, it basically sets up all the sprites for you. And a lot of the time, see in pictures, we have all these different costumes. So like I said, this is really an apple and orange program. Just for trading, they call it apple and pear. Doesn't really matter. But so you see in this picture sprite, all these images are set up for you. And that's a big hassle for you to have to get the kids to set up, which is why these templates are really useful. So if I just show you the completed version. Oh, and Sneha, I'm sorry, I don't know how to pronounce your name. So, but let me know if you have any questions. I'm just going through the kind of the material that we're working with here, and also general tips or things that problems that I've encountered and how I like to solve them, or general ways I like to go about teaching class. And feel free to stop me if you ever have any questions. And I also tend to talk a little fast naturally when I'm teaching to kids. Gotta slow yourself down, make sure that your kids are understanding everything every step of the way. We just have a lot to go through. So this is kind of like what would be your completed version. Sometimes when you open up these projects, they delete your ML blocks. So the ML blocks are right down at the very bottom on the left here. And they're kind of like a teal color. And if prediction equals, and it kind of deletes them sometimes if you reopen them, then you gotta put them back in. Sometimes they do like comments. So add comment, say apple, so that I don't forget that that's what's supposed to go in there if it deletes itself. So this program, it's not gonna work right now, like I said, because the machine learning isn't working on the platform, but it kind of goes through each image and would be giving me a prediction. The sound effects, stuff like that, that's just extra little glamour. You see, it says prediction unknown, confidence 0%. It's not working right now. But basic idea here, you see all these teal blocks, they are these ML blocks that you're going to be working with. They'll always be at the very, very bottom of this left bar. And so it says recognize image label parentheses. So the output is going to be the label. Either apple or pear or apple or orange. Confidence is gonna, you see in parentheses, that's gonna give you an output of a decimal. So then I would have to do some math here with my students if they want to see it as a percentage, multiply by 100, add a percent sign. Some of them might have learned that in class, like in school already. Some of them might not have. So you want to make sure, and you might have to teach that to your students. And then after that, confidence honestly isn't really even, you don't even need it. It's not even part of the project really, but it's nice to, kind of reinforce these concepts that you just introduced them to. The idea is, I think over here, I like to put sticky notes on my page in the sprites as I explain certain concepts. So you see here, I'm explaining percentages. 1 is equal to 100%, 0.99, 99%, kind of explaining how to convert decimal point into a percentage. Over here, you see, I'm kind of explaining how, what these are kind of working at, what these are looking like. So this says recognize image. It's recognizing the costume image, right? That's what it's looking at. And so I'm kind of explaining that here, the concept of inputs and outputs to the students. And so I'm kind of also explaining, this is how functions work. This is a function, which is often used in coding. Like some of these students, they might also be taking like a Python class. Some of them are already working on like coding stuff like that. So it's good to start introducing them to these like fundamental coding concepts. Some of them learn like inputs and outputs in terms of like X's and Y's if they're taking pre-algebra. So that might be a good way to talk about it as well. Yeah, this program is pretty simple. Flag clicked, set the prediction, set the confidence, broadcast prediction made. Once that's broadcasted, our little robot is gonna say, if it's an apple, say apple, otherwise say orange, broadcast next image. What you can also do here, I actually did that with my student for this session right now. So you see for next image, I'm kind of just using the same code as I did in the beginning, right? Because I wanted to repeat the same thing. set predictions, set the confidence, broadcast the same thing. If you're familiar with Scratch, you can use my blocks. And my blocks are kind of like methods, I guess, or functions. I guess more like functions that you can call over and over. And so if your student is ready for that, you can also utilize a my block to do this. So over here, I just used a my block to run this same code again, instead of writing it out twice. So my blocks are introduced, I think, in like the third project, but if you have a student that's already experienced with Scratch, you can take this route as well, right? You always want to, you know, teach your students the most efficient ways, the ways that you would want them to do it. Don't take roundabout ways just because you think like, oh, they're not ready for it. You know, you always want to try and teach them the best way to do things. Questions about this apple and orange project? Okay, yeah, for this one, I also have it saying the confidence. This is an orange, 0%. Yeah, typically after I go through, let's kind of like the basis or the basic requirements for the project, I usually give the students at least like 5 to 10 minutes to kind of play with the program on their own. A lot of these kids are like really creative and they come up with a lot of cool things. So if you give them that time, like that creative freedom, they'll add a lot of stuff to their project. It just, what you need to be careful of is that, you know, so that when you're going through the project content, those kids don't derail. Tell them that you'll give them that time later so that they don't just start, you know, doing whatever they want while you're trying to teach the course, because then they get a little off track. Okay, next project, I think we can talk about. Oh, and one other thing, I usually don't use this a lot, but it's helpful in the beginning when you're still getting used to it. You also have these lesson plans. And if you open that up, it's just this PDF of, you know, a detailed lesson plan of that project. So it says apple, pear, tells you exactly how you should be doing it, the agenda. So this is what's covered in the PowerPoint. It says intro to ThinkLand. So setting up your kid with the ThinkLand platform, and then the project. And then it gives you like answer keys here. I guess it doesn't include the code because it's not too complicated here, but usually also includes like the code. So you see, like for the next project, we have the Spongebob project files. If you download those and then open them in Scratch, it's the completed project. It also should be in the lesson plan. Open that up. Yeah, I see these are, you know, kind of answer keys to what the code should look like. Sometimes I found better ways to do it than it's found in the answer key here. You know, you can experiment on your own and see what works best for maybe your code. And so the next project would be Spongebob. This is working with image recognition. You go into the presentation. Again, same thing, maybe make a copy of this, maybe edit some pages, take out some pages, add in. You're really given a lot of liberty here, so edit it however you think would be best. And so this is kind of going more in depth about what is image recognition specifically. So we do a little bit of review, refer back to Pictionary we did in the last lesson. What is image recognition? How does it look like in real life? Sometimes they kind of say, oh, what's this car? You can see it in a slideshow format a little bit better. Oh, it's a Tesla, it's self-driving. Kind of explain Teslas, you know, they're using image recognition to recognize what's around them, to drive on their own. Oh, what does this blue text say? This looks like sharks, you know. This drone is flying over the ocean and detecting sharks. If we looked at this, you know, we can't tell the difference between a dolphin or, you know, whatever the shark might be, but this drone is able to use AI to tell that these are sharks. Then we get right into training the models. You see, this is a lot shorter than what was the first presentation. So we did the apples and pears before, but now let's do SpongeBob and Friends. And so this is like the little prompt. It's going to be a program that's going to send Spongebob and Patrick to their houses and then everybody else to Blue Lagoon. And then you're going to train and test. It kind of tells you. And then these are little questions that are supposed to help you with the coding. Sometimes I use them, sometimes I don't. It really depends on what the student is looking at. If the student, some of these are very basic questions. How is the character sprite moving? Do you know how to do that? These are casual things you can bring up during the coding process. It's not always necessary to go through like a presentation because kids will see this and be like, oh, I don't like listening to lectures or whatever. Some of these that are useful, you want to go down here. But yeah, you should always like keep these questions in mind for, discussion during the project. And then this is a little bit more about image recognition. What does image recognition really look like? AI doesn't look at pictures the same way we do. And this is kind of showing the way that machine learning or, AIs can look at these images, how they're seeing similar shapes. Because, you will encounter instances where you'll get the wrong prediction and kids will be like, oh no, why is this wrong? You have to talk about maybe why. It could be you have bad training data. It could be you have biases, which also come up later. It could be, machines just don't work the same way that human brains do, even though they may mimic in the same way. So if I open up, let's close that. The Spongebob ML. So our labels, Spongebob and Patrick, enter the training data. Same ways before. Usually the drag and drop method is the best. If not, try and do the copy and paste with the image address. Go to number 3. Your machine model you should click train. It should be trained. And then test it. Again, try testing maybe different characters. Try testing different types of images of Spongebob and Patrick. Look at the confidence level, review that with them. It's really important to reinforce it every step of the way. Again, project templates and your Spongebob empty base. And so this kind of sets up all your sprites for you. You have your character sprite and a bunch of different images in your character sprite. So yeah, this is going to make the process a lot easier for you. So if I open up one that I just completed, okay, see how there's kind of a lot of notes on here. What I would do is these are coordinates, right? So I was just putting notes for their locations. Like this is the rock, this is the pineapple, because you're gonna have to move them around while you're teaching them how to code this. See how I have a note? This should be Spongebob right here because it kind of deleted my ML block. And again, I'm putting notes, right? Try to think about how we can make this work better. This is our extra time after we work on the project together. Okay, guys, take some time to work on this on your own. What can you do to make the code better? Oh, this is also general discussion about machine learning specifically, but you can also say, what can you do to your code to make it better? Or do you want to add sound effects? Do you want to add visual effects? Whatever it may be. And this project specifically, people or IGO Learning kind of presented in 3 steps. So this, if you check out, let's go back. If you check out the lesson plan, it says you can teach it in 3 steps, which I think is actually a pretty good way to do this. Part 1, do the animation. So send 1 picture of Spongebob to the right location. Part 2, send the first 3 to the right locations. Part 2, send the first 3, and then part 3, now send multiple and implement the AI. Just the thing about this is that when you have these kids doing it in these steps, you're gonna have to do some restructuring between each step, like doing from part 2 to part 3. It's gonna look a little different. You have it right here, actually. Like part 2, you have, if it's the first one, go to this location. If it's the second one, go to that location. Else, so the third picture, go to that location, right? But over here, you're gonna have to make it look a lot different. Because so this is location is, I think, pineapple, the rock, and then Goo Lagoon, I think. The reason why I add notes is because you're gonna have to kind of move these around sometimes. So what you're first gonna have your kids doing, you're gonna say, okay, if it's SpongeBob, go here. If it's Patrick, go here. Otherwise, go here. But like we discussed, there is never gonna be like an otherwise. This isn't included in the agenda actually, but there is never gonna be an otherwise. You're only ever gonna have labels SpongeBob and Patrick, SpongeBob and Patrick. That's the only cases, you're never gonna have an other label. So in this case, you're gonna have to restructure it to use confidence. And so what I would do at the beginning, I say if the confidence is very low, then go to Goo Lagoon. Because as you test it, you kind of know that a lot of the time when the confidence is low, it's gonna be a character besides SpongeBob and Patrick. This isn't like a surefire way to tell, but it's better than nothing, because if you have this program, it's only ever going to categorize it as SpongeBob or Patrick. So first I kind of filter it out using confidence here. So you have to move the Goo Lagoon location to this first one, and then if who am I equals Patrick or SpongeBob, then go to their corresponding locations. So you're moving coordinates around the place. That's why it's kind of important to keep track. I can show you that over here. If confidence is, I have it less than 99% here. This is like a number that you can ask your students to play around with, see what works best. Glide 2, this is Goo Lagoon. Then who am I equals SpongeBob, glide to the pineapple. Otherwise, has to be Patrick. So we're gonna go to Patrick's house. I guess the whole point of using these notes, just making sure everything stays in order. Because when you start moving things around without labels, it gets very confusing, especially if they all look the same. Kids can lose track of this very easily. Any questions about the SpongeBob project? And I just speed ran through it. Okay, and then we're gonna have the simple smart home. I'm gonna leave like 10 or 15 minutes at the end for questions if we have any. Yeah, simple smart home, same idea. First, look at the lesson plan, kind of read through this. And it kind of explains how for this one, there's 2 possible templates. One that already has some of it coded in, and then one that's pretty empty. So for this one, it's going to be pretty empty. This one already has the backdrop script coded. And you can decide, as you've been through the first 2 projects with your class, which one would work better for them. And see the agenda kind of goes through all the steps and has an answer key that you can refer to. But you can also download those project files, like I said, instead of using the answer key. Download it. You can download the files to your laptop, open it in Scratch, and then really see how the completed code works. So you should really be doing that beforehand, at least once, so you know for sure what you're doing, and you know for sure that it works. Again, open your presentation. Sometimes kids are very eager to get on with the coding part, so it really depends. Sometimes you can go and do the non-machine learning part of your project first, then come back to the PowerPoint, go through the machine learning concepts, then do the ML model. You can do it in a different order if you want to. You don't have to go through this first necessarily. So then talk about how do humans communicate? How does that work with, how does that compare to machines? So this is natural language processing specifically. Yeah. So then you're going to open up the ML. So you have this in this case. So it's a simple smart home. It's kind of like those smart homes that you tell Alexa to turn on the fan or whatever. and then the fan turns on, turn on the Roomba, clean the house, turns on the Roomba. So the idea is that you can have different ways to say the same command or show the same intent. And so that's where our labels are these commands: fan on, fan off, Roomba on, Roomba off, etc. Training data. So this is language processing. So it's different ways to say the same command is the idea. So Roomba on, turn the Roomba on versus Roomba on, or clean up or make it clean, all the same way, to all the different ways to express the same intent. And so you see here, there's a lot of labels. You're only required to do 7 for each instead of 10. So like I said, it can look different for each one. Train the model over here. So this one's just learning done. It's still not going to work, but I'm going to go and launch Scratch. So I'll show you the 2 different templates. So this one is the empty base. This one has a couple things already coded in. It has this TV thing coded in. Doesn't have any of the other appliances coded. Nothing in the backdrop. The other template, this one has everything already coded into your backdrop. That's the only difference here. And so this is kind of saying, this is kind of coding this whole part for you, where you can type something in and then it corresponds with the right broadcast. If you use the other template, you have to code this all with your students. And so you can decide if your students, they're ready for that, or if they're kind of falling behind, you're moving kind of slow, you can just use this template so you have more to work with. And so if I show you the completed version, the order that I kind of like to work with this is I first work with this TV, because this and this, the TV on and off, are already coded for you. So I play it.
Wait, Spongebob, we're not cavemen.
So I show the kids how, we already have the code there for us. So I kind of walk with them through it. How is this working? I kind of compare it to like a flip book. So forever, it keeps moving to the next costume. So it's moving to the next costume after a certain amount of time. Sometimes I have them play with the weight and see how that affects it, makes it slower or faster. And then I show them, look, if I click through this really fast, it looks like it's moving. So I compare it to a flip book. And the reason why I go through this with them first is because the fan works with the same mechanism. And sometimes I let them code that on their own, because the fan also works in the same way as like a flip book. So pretty much similar, same exact type of code. And then, so I'll sometimes let them work on that on their own. For individual versus group work, most of the time I work as a class first. Then, starting here, you have a couple of different appliances to work with, so I can let them code on their own if they're comfortable enough with that. I usually find that group work is a little bit awkward, especially virtually. If you have like maybe a class of like 5 or 6, you can make like 2 rooms and it might work. But usually I'll kind of stick with individual work, if anything. And then group work, if that, becomes an option, because some kids really enjoy that. Some kids really do have fun working in groups. So we have lamp. The lamp is also the simplest one. So I would also kind of do that first, if to kind of introduce them to the idea of these broadcasts. Like I said, the fan is the same concept as a TV. This is actually a lot more complex than what's in the lesson plan. So if you check out the code for the fan in the lesson plan. Oh wait, this is Spongebob. Oh no, this should be the right one. Let's see. Yeah, so the fan is also not too complex. It's really just when I turn fan on, keep spinning, next costume, turn fan off, turn the fan off. You don't even need the variables really, but over here, what I was doing with my class in the spring session, someone wanted to try making a slowing down animation. This was like, after we're done with all the components of the project, this is like free working time, right? What do you guys want to work on? I asked. And one of them was asking me, oh, can you help me with this slowing down animation? And so that's kind of what we did. It's kind of, I have to broadcast, find a broadcast here. When a broadcast turn fan off, oh, that's not going to work right now. But we were kind of working with, I think this worked before, but we were working with a turn, instead of just simply turning the fan off, we kind of work with a slowing down animation where it would slow down, wait an increasing amount of time each round, and then eventually come to a complete stop. The Roomba is the most complex, so I'd say work on that as a class. If you're not gonna work, if you're letting them work on their own, you could let them attempt it on their own. But then I kind of like to come to it as a class and go over it all together. I kind of talk about two different ways to do this. We have an if you're touching certain objects, then bounce. And then you also have a repeat until you're not touching these objects, bounce. So these two methods I kind of talk about, in essence, they're the same thing, right? Logically, but they kind of work a little bit differently just because of the way that Scratch processes it, especially because Scratch is a little bit slow. I find that, this one sometimes yields less glitches than this one. But I kind of like doing stuff like this, especially if, you're moving ahead pretty well with your class, because when you show them that there's more than one way to achieve the same thing, it kind of opens new doors for them. It encourages them to think flexibly, it encourages them to also think what is the most efficient way to get things done. Because these students, they might have experience and exposure with Scratch, but a lot of these things like using conditionals, using loops, they don't really know how to make the most efficient program. So something like, this, I feel like it's really good to go through with them and just kind of show them there's different ways to achieve the same thing. You can also make this fun, like, the pen is part of the program, but I was showing them, oh, you can make it a rainbow by using the change color. They really love that kind of stuff. So it's really good to kind of, have fun with them and try to show them, you can do a lot of different things. Some things that I also tell them in their free working time, oh, like, why don't you try adding like sound effects to the fan, like a fan sound, or what if you add like a clicky sound to the lamp, sound effects, visual effects. Again, encourage them to try and explore a little bit whenever you can. Praises and criticisms would be the last project in session 1. Again, same idea, lesson plan, presentation, go into the ML. So this one, it's kind of the idea that you're gonna say like, oh, you're so amazing, and the ML model has to distinguish it between a praise or criticism. You're gonna say, oh, this is absolute trash, and they're gonna say this is a criticism. I think this is like, again, getting a little more interactive, right? The first two projects were kind of just letting the program run. The last one, with the simple smart home, and this one, you get to interact with your model. And kids like it when it's like there's like a game element to it. So this one I found is a little bit buggy. I'm just gonna show you guys the completed one. Let me use this one. This one I found is a little bit buggy sometimes. Just this one, there's this one aspect here that's new. You can save phrases, and then there's a feature that says add training data. And so before, the only blocks we were using is the recognize blocks, but we're starting to use this add training data. And so what that's supposed to do is it's supposed to so we're saving phrases to these lists. You click add new training data, and it's going to take that info from the list and add it back into here. And then there's also a train model block. So that's also supposed to train it for you. So the idea is that you're kind of teaching the model these confusing phrases as you go. Before we couldn't do that. Before that wasn't introduced, you just deal with the model that you made before. But this one you can update the model as you go. I haven't been able to find a way to make this work. It's pretty buggy, but if you play around with it a lot, maybe you'll eventually find a way. Because sometimes what happens, you can't, if you have one in, sometimes it'll add like empty boxes, or sometimes it just won't completely train it. As I said, it's quite glitchy, so you can honestly skip that part of it as well. That's the only thing I'd say about this project. Everything else, you can see that this is pretty long code compared to what we had before. So I would also work with this with your students. The individual part, I'd say you could do the buttons individually. Some of the buttons have like almost identical code. So you do one of them with your students, then say, okay, try this one. This one works the exact same way, maybe with these differences. So what I do with every button, I make Post-it notes to kind of walk through exactly what they're doing. All these Post-it notes. And that kind of helps them, see what exactly is happening in the code. One other thing I'd say, I used to do this actually on the Google Doc instead of putting it on a Post-it note, because I found it easier if I could see all of the notes at the same time in one page instead of flipping through it all. But I feel like this Post-it note version, it allows me to keep things in one place instead of making like a new Google Doc they have to refer to. So I do that, and then I also like to use like a class notes and code doc. And so I usually add this into the dashboard of the class, and I update this as we go along through the course, because when kids miss classes, or maybe they just missed part of class, they came late, this kind of helps them catch up with the code. So just put screenshots here for whatever we had completed in class. And it also has all the notes with the Post-its. So one final thing I want to talk about with troubleshooting, if you're teaching session 1, if you're moving pretty fast, you might also do this space log project. I've done this a couple of times because pacing doesn't always work out exactly the way you want it to, and there's no reason to unnecessarily slow down the pace to it's going to bore your students. So you can always do the first project of the session 2 project. And so here, it's everything the same idea, but one thing that you might have to troubleshoot with is downloading files. So this is called Face Lock. It's kind of like an iPhone project where you have like an iPhone in Scratch. I can open it actually. You have like an iPhone, and it is reading all these different images. And so what you have to do with your student, you have to make them download this Google Drive file. You go to Drive, it's a zip file. And then you have to click download and everything. Like I said before, students don't know how to use their laptops, and they can't access things from their files sometimes. Sometimes they don't know that, they just don't know how to access these downloads. So what you might have to do, if that doesn't work, you might have to tell them to maybe take pictures of their own face. That's where the webcam comes in. Maybe upload pictures of their own face and their families, or upload another solution that we came up with last time is use celebrities pictures. If you have like Ryan Reynolds, you can use that as the me, and then use other random celebrities as the others. That one's a pretty good idea. So you might have to come up with other methods to do this part if you're having problems. Usually like at least one student just won't know how to do it, or it just won't be working for them, Just the one problem with that, if they have to do, their own pictures or celebrities' pictures here, they also have to make that modification in Scratch because, it's not going to work with these costumes. So they're also going to have to do a little bit of extra work and download pictures or upload pictures for the costumes so that it'll work properly. Yeah, that's just one note about this. Besides that, I really like this project. Even if you don't get through it with your, level 1 class, it might encourage them to, if you want to finish this, go sign up for your level 2 class. They like seeing this. I think, and this is, again, it's getting more interactive, right? Kids like making Scratch games. So it's a really good way to get them into it. In general, I'd say don't be afraid to make small talk with the kids. It's okay if, you spend some time looking at projects that they made. They're really eager to share things, actually. And a lot of them will have worked on Scratch on their own. So they'll be like, oh, look at this Minecraft game I made. It's really impressive. Or you can always make small talk with them at the beginning of class, whatever it may be. This is my recordings folder. In your class reports. Oh, I should give you guys that link. So this is a video link for, say, general class procedures. You're gonna have to do attendance every time. You're also gonna have to do class reports. That right now I'm just covering, material for the Scratch class, but these are also things that you should keep in mind for teaching any class at all. And so for class videos, a lot of the time, just make a Google Drive link, upload them all to Google Drive so that, the teacher will kind of have, or the parents will be able to look at, any video from any class. I feel like it's a good way to organize. You can tell that I'm running out of iClouds, out of drive storage. That's not good. But, I feel like that's a pretty good way to do this. So yeah, I keep, copies of these slideshows, edit them how I like. But yeah, that's it. I can go over the evaluation material if you'd like me to. If you guys also have any questions or you need to go, that's fine as well. Any questions for me? Is there anything that you guys want me to go over at all, or?
The evaluation thing you said.
Yeah, sure. So I think they changed eval so you don't have to zoom. It's just a recording, right? You just have to do a recording of yourself right now. So this is the lesson plan. You can read through this to help completely, understand it, but I'll just really show you what we're working with here. So, you just obviously, in the recording, you want to keep your camera on, be cheerful, just be like, hi, starting with this. Where is it? Bouncing ball. I would say the bouncing ball, the code isn't too bad. There is a little extension it says you can add, right? Extensions create trailing animation. You don't have to do that. That's extra work. It's a little more complicated. But this is without, this is with machine learning. So let me show you with that, just so it's easier for me to explain. Okay, so the idea is that you're making this bouncing balls game, must look familiar, right? You're just kind of bouncing this ball to you're keeping track of score. Every time you hit one of these blue blocks, they're going to disappear. When you hit the floor, the game stops. So right now I'm just showing you without machine learning. So this green block is just moving along with the X value of my mouse. This ball, if it touches the block, then it's gonna play this bounce code. If it's on the edge, it's going to bounce. If its Y position gets lower than this negative 140 value, the game ends. So that's the lose game. That's the lose condition. And so this bounce code, it's just moving in the opposite direction, and it's using a repeat until not touching. And then it moves forward until it's not touching the block. So that's like the same idea as like what I was talking about with the Roomba before. This brick, it's just a 4x7. It's a 4x7 type of, I guess, setup. So it's gonna repeat 7 times, create a clone. So 7 times across, move back, change the Y, then make 7 across. So it makes like a 4 rows, 7 columns. When I start as a clone is, how you do code for clones forever. So you're always checking if you're touching the ball, then you change the score and you broadcast bounce, then that triggers the bounce code over here. But yeah, actually you don't really even need that, to be honest. Or I guess you could take this part out because that's a little repetitive because you're checking if you're touching the block twice on both sides. But honestly, I guess sometimes things like that could help because of the way that Scratch is really laggy. Like if the ball was moving really fast, it might not process that it touched the brick until like it's too late or something. That's something you always have to keep in mind with Scratch as compared to other whatever you're working with in coding, because Scratch can be slow sometimes, and that is the cause for a lot of glitches. So you might have to like adjust the way that you code, even though the way you code should, logically work, it might not always actually work in practice. Questions about this eval material? Oh yeah, sorry, I did not show you guys the machine learning part. So here I just had it as controlling the green block with my mouse, right? With machine learning, you want to use this thing called pose detect. I don't really think you're going to use it in the course. Pose net. Just turn video on. You already see my, my room and myself in the video. And so turn video on, set video transparency, forever, start pose detect, go to. And so in this case, it's going exactly to where my nose is. So I have to move around and try to get the ball. I think the more efficient way to do this personally is if it just controls the X value and not the Y value. So it's like at the bottom of your screen. Because right now it's following my nose position exactly. What I would personally do is I'll actually take out the Y value. I feel like this is a little bit better. So now it's just moving at the bottom. But yeah, I think the agenda or the lesson plan tells you to do it like this. But like I said, you're really allowed to make a lot of adjustments. No one's going to come after you for changing things. And I think it's better if you do that way. You find out through practice what works best, and you find out the best way to present things to your students. Anything else to go over? Okay, then make sure you guys look at that YouTube video that I sent you guys for general class procedures. It's really, really important because I didn't have time to go over it in this course. But yeah, I hope you guys best of luck with your evals, and yeah, feel free to, I guess, ask any questions. I'll be staying here for another 2 minutes, but you guys can leave for now.
I'm not sure what email you sent out. I don't think I received it.
Oh, I sent the YouTube link in the Zoom chat.
Oh.
Do you think you can see it now? Yeah, sorry if I misspoke. But yeah, that YouTube link is very helpful. So you're free to go. I'll stay for another 2 minutes if anyone has any questions.
Do we stay on this Zoom meeting? Or are we done for the thing? I thought there was going to be more, or no?
There will be more. Another teacher will be coming. If you're planning on staying for other classes, then yeah, you could stay. Or is there another particular training course you're trying to look for?
I'm not I just click on the email to join the meeting, but I'm not sure what to do.
Like which course do you want to learn about?
I guess all of them. I don't know.
Okay, then yeah, I think you could just stay for the day. The next session is, yeah, it's gonna be starting at 1 p.m. actually. So yeah, the next session starts at 1 p.m. for the Math AMC 8. I can send you the image again if you the image in the chat if you'd like for the agenda. Yeah. Let me upload this. Okay, so I uploaded a file into the Zoom chat that contains the schedule for today and tomorrow. Let me know once you got it.
Yeah, I got it. I just don't know how to download on Zoom. It's kind of a little funky.
You're good? Okay, so next class is starting at 1 p.m. so you can come back in an hour. So I'll close this Zoom now, okay? All right, thank you guys for listening and good luck.
Thank you.
Yep, no problem, bye.